All right, here's the video lesson for problem number 30. I did 29 already, and I realized I should have probably done a video for this one. But this is the way this one works, because 29 is not easy. It involves factor by grouping. All right, but before you can start that, you got to realize that these two guys right here kind of need to be the same. And they are the same. And it's just like a little trick, right? So if you have A minus B, it's exactly the same as B minus A with one exception, right? So if I have B minus A, right here, and I factor a -1 out, I'll end up with, wait, hold on, pizza's here. I'm back, I have my pizza, came back with my pizza, and desk was a little messy, so I thought I'd put the pizza down on the plate, on the carpet, clean the desk. Forget the fact that the pizza is on the ground, on a plate, on the carpet. Step on the pizza, get pizza footprints on the carpet. So it seemed to you like it was a split second. It was like 10 minutes. All right, I'm back. So you have B minus A, popped out a -1, now I have negative B. Because -1 times negative B is positive B. Then I go over here and I say, all right, well, -1 times what is negative A? -1 times what is negative A? Well, that's positive A. And then, whoa, that's the same thing as A minus B. All right, so you have that right there. Same as that. So now that you know that, if you ever have like a x minus A and you need to turn it into an A minus X, you just go -1 times A minus X. So those two things are the exact same thing. All right, let me erase that. So over here, I was like, all right, well, X minus Y, same exact thing as what I do over here. Popped out a -1 and made that which is now the same thing as -x plus Y, which is the same as Y minus X. See, Y minus X, which is the same as that guy over there. Got my -1 right there. Didn't do anything over here. And then I have, put those two, so 5 times -1 is -5. And that's what I have. And then what you want to do is you want to look for, this whole method is called factor by grouping. And when you have factor by grouping, the way you know you have factor by grouping, first of all, I didn't say that. Well, this isn't the best example, but usually you have 4 terms. So what I realize I have right here are twins. It's the same exact thing, right? It's kind of like if I had, you're supposed to say right, by the way, -5 times A. That's the same as if I had like -5 times A plus Z times A, right? So there's my A, there's my A. How do I factor that? Well, I pull out the A, then I end up with -5 plus Z, right? So A times -5 is -5A, and Z times A is ZA. All right, so that's what happened right here. Got my twins, whoop-how, and then I factor out, I popped out the A basically. That's like my A. There it is, boom. And then I'm left with -5 plus Z, and then I put it together, and then I remember that some teachers are picky, and so I was like, all right, well, usually they don't like to have the negative thing in the front, so I'll put that in the back, and so I'll go Z minus A, and that's that. All right, number 30. This is legit factor by grouping problem. The reason why I know it's factor by grouping is because I have 1, 2, 3, 4 terms, factor by grouping. So what you do is you go, wait, I'll write up here 4 terms. 4 terms. Let's see, right here, so you see like, all right, what can I factor out? I can factor out an X. So I'll take my X out, that leaves me with an A plus 2. If I distribute back in, I got my XA plus 2X. Then over here, there's nothing really to factor out, but it's all good because I have my twins. Twin, twin, right? But really, what I have going on here is I have a 1 times an a plus 2. You got an invisible 1 right there. All right, so twins. Make sure you say it like that in class while you're taking the test. Like that. Then I have x plus 1, or however you want to do it. I just give it like this. I say, all right, write down just the outside guys. All right, x plus 1. Check. And then I say, and then one of the twins, x plus 2. I mean, a plus 2. Close. Answer. So that's factored by grouping. Don't really need an arrow there. Okay. 31. All right, 31 we have x to the 4th minus 1. And that is a difference of squares. That's kind of like if you have like an x squared minus 9. How would you factor that? That's x plus 3, x minus 3, because you end up with a middle wipeout. You get your x squared, your minus 3x, your plus 3x, and your minus 9, and your wipe, and your wipe. So that's a middle wipeout problem. So this is also a difference of squares. You can't do a sum of squares, by the way. This is not happening. This not, you know, x plus 3, x minus 3 business. That's prime. Like, we got a plus right there, done. But you got a minus, difference of squares. So you're gonna go, all right, so you have x squared. All right, well, really this is x squared, because when you have a power to a power, you multiply, minus 1 squared. So difference of squares, right? That's the same thing as x squared minus 9, because that's really x squared minus 3 squared. And if I did that, it'd be take the square root of that, and take the square root of that, and do it again, and then opposite signs. All right, well, that's what's happening here. So take the square root of that whole thing, which is x squared, and then take the square root of that whole thing, which is just 1. And then you do it like opposite sign, buddy, right here. Now watch this, because this is where the teacher gets you on the test. And this will be on the test. Guaranteed, I think, because teachers love to do this to you. And your teacher seems like the kind of teacher that would love to give you one that you get wrong and be like, aha! So it's right here. That right there is still a difference of squares. Again, like this guy right here. That's a 1 squared. So well, this needs to be not really, don't really need those arrows, maybe one like that. Difference of squares. X plus 1, x minus 1, and this one's over here, like that. X squared plus 1. You can't, that's a sum of squares. Like I said, you can't do anything with that. So that's your answer. In your face, Mr. Whoever you are, teacher guy. All right, next. 32. All right, I got x squared times y minus y cubed. All right, so this looks like a what can I factor out thing type of problem thing. All right, so I can pull out a y, then end up with a x squared minus y squared. Oh yeah. Now I know why it's in this section. So you put it back together again. You have your x squared y, and you go over here, you have your y cubed, and then you think you're done. And the teacher's like, haha, 1 out of 4 points. Because right here you have a difference of squares. You have x squared minus 3 squared. I mean, you don't have that, but it's similar to that idea. Like x squared minus 9, we gotta do x plus 3, x minus 3. Got it right here again. So you gotta go like that, then you're gonna go y, and it's gonna be x plus y and x minus y. And if you had a plus there, you wouldn't be able to do that. All right, that's done. All right, next problem, number 33. 33 is 9m cubed minus 63m squared plus 108m. All right, so this is I forgot to tell you what the first rule of factoring is. First rule of factoring, you do not talk about factoring. Just kidding. First rule of factoring is you see what you can pop out. That should be done with any problem. So, what is 9m cubed and 63m squared and 108m have in common? B. They have B in common. So you factor out the m, then you go, all right, well, I have 9m squared minus 63m plus 108. Right? So m was in common. Put this back together again. I get 9m cubed minus 63m squared plus 108m. All right, so I didn't really check to see if they have something else in common. That probably would have been a good thing to do. All right, so maybe 3 can go into all of them. Well, let's see. Can 3 go into 9? Yes. Let's see. Can 3 go into 63? Well, 6 plus 3 is 9, and 3 can go into 9, so yes, yes, yes. And 1 plus 8. Let me try that again. 1 plus 8 is 9, and 3 can go into 9. That's an 8. So 3 goes into all of them. So we pop out a 3. So we got a 3m. All right, so we got a 3m squared, which is 3 times 3 is 9, minus 63 divided by 3. Quick mental math. 21. 21m plus 108 divided by 3. More mental math. 108 divided by 3. 36. That's 36. 36. All right. Oh, jeez. I like to change my number to pop out. It would have been better if it was 9, because it turns out 9 goes into all of them. But have no fear. We just keep chopping down by 3s. Pull out another 3. So now we have 3 times 3m. So then 3 divided by 3 is 1, leaving us m squared. So 21 divided by 3 is 7. And then 36 divided by 3 is 12. Now we have that. Then we're left with 9m. And we got our m. What do we have here? We have to get 12. So we got to see what adds or subtracts. What multiplies to 12 but adds or subtracts to give us 7? So I'm thinking 4 and 3. I'm thinking -4 and -4 and -3. And I'll check using the FOIL method. FOIL. All right, got my first straight, m squared. I got my outside straight, kind of, sort of, -3. I got my inside straight, kind of, sort of, -4. They add together -7. Check. Got my last straight, -4 times -4 is positive 12. Make sure there's nothing inside that's like a difference of squares, because they're going to try to get you like that. Make sure it's like not one of those type of guys, and it's not, because if this was a square, it would have been, and that would be like m plus 2, m minus 2, but it's not. So we're done. Okay. You get that? Good, good, good. All right, next one is 34. We have a squared plus a plus ab plus b. We have 4 terms. And what do we do when we have 4 terms? We cry. That's what we do. Then we regroup and we think about what we're going to do. And say, oh, wait, that's factor by grouping. Yeah, we did that. Go back over here. Go over here. Say, all right, factor by grouping. That's the one that Steve was talking about with the twins. All right, well, let's see. We have a. We got to see what we could. Wait. Watch this. Pure talent right here. Look at that. It's 42 years of just working on those. All right, you have pulling out the a. You have a plus 1. Over here, pulling out the b. You have an a plus 1. Hold on a second. All right, so b times a is ab. B times 1 is b. And that's a positive b that we pulled out. If it was negative, it'd be negative, but that's positive. And we have our twins. So pull out the non-twins, those guys. If you missed that the first time. Now it's an orange. Those guys. So we pull them out. We go, all right, that's a plus b. And one of the twins. Don't forget to scream that really loud in class. 35. 35 is, let's see. Okay, so these, we never did these. These are different. So this is how this goes. All right, we have 41x equals negative 60. All right, so in order to solve these problems, I'm going to show you a really, really bad way of solving this. I got to make a point of it because it's just wrong. So here's the wrong way. I've done this before. It's blown up in my face. The wrong way of solving this is doing this. All right, here. I wish I could like imitate a stupid voice. So you go like, you pull out an x, and you say, all right, I got a 3 and an x, and then minus 41 equals 60. And then you say like, haha, x equals 60, but I'm an idiot. And then over here, I got, ha 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 ha, 3x minus 41 equals 60. I'm also an idiot. So that's wrong. You don't want to do that. Do not ever become a tutor and accidentally do that in front of a student and become really embarrassed. So what you want to do instead is go plus 60, plus 60, all right? It always has to be 0 over here, every single time when you do this technique, all right? Gotta have a 0. Don't have a 0? You're stupid. Just kidding. All right, so you have 3x squared minus 41x, and then plus 60 because we brought that over. See, plus 60. All right. So let me write it again because that looks ugly. 3x squared minus 41x plus 60 equals 0. It's easier if you can see if things can pop out, but I know that 4 plus 1 is 5, so 3 can't go into 41, so there's nothing we can pop out. So then what you do, you factor. You go did it equals 60, and you say, all right, well, 3x and x, that gives me my, oh, this is a harder way of factoring, by the way. Yeah, 3x and x gives me my 3, and then you think, hey, what gives me 60? And then you realize, wait, this is a harder way of factoring. I don't play that game. It doesn't work like these other guys. See over here when I was like, did I do that ever? Oh, wait. Here I was like, hey, what gives me 12? 4 and 3 give me 12, and they added or subtracted to give me 7. That does not work when you have a number in the front. You have to roll the dice. You have to say, I can say what gives me 60. Yeah, I can do that. But you can never, never, ever, ever say like, what gives me 60 and adds or subtracts to give me 41. Not going to work. So you say, all right, I'm going to say off the top of my head, 6 and 10 give me 60. 6 and 10 give me 60. All right, well, let's see. So you do your outside to check. And I say, all right, 18x. Okay, 18x. And then over here, inside check. So you're kind of doing Floyd, by the way. So you set your first, you set your last, and then you check your outside and inside to see if you're right. So I set my first, right there. Set my last, and I'm checking my outside and inside. And that's 10x. And 10x and 18x in no way on any planet that I know of gives me 41. So you back up. I really kind of like that there. And we're going to go back up, and say, all right, that was wrong. That was wrong. I could put a 6 and a 10 over here, but that just made a 30 and a 6. Not helping. Back up. Let's try 15 and 4. Everybody knows that's 60. So we have right here 45. That's kind of interesting. That's interesting. And over here, 4. Still interesting. So we have 4x. We have a 45x. And we think, all right, well, how can 45 and 4 come together to give me negative 41? So we go into our thought bubble. And we say, well, 41 is more powerful. I mean, 41 is negative, which means the more powerful of the two numbers has to be negative. 45 is more powerful, so it's going to be negative 45 when it's up against the wimpy 4. So that means I have to have a negative 45 and a positive 4. So I go, well, then the outside gave me the 45. right? Well, that's already positive, so this has to be negative right here. And then the inside will be positive because it's been positive 4. Then you can check it. You should check it. You do, all right, Floyd. It's my first right. Cha-ching, 3x. This is my last straight. Cha-ching, negative 60. This is my outside good. Negative 45. And then my inside plus 4. Negative 41. We're good. And so, not done with the problem though. Don't make that mistake. You're like patting yourself on the back. Dude, I just factored this awesomely and didn't actually answer the question. So we got 3x plus 4, x minus 5 or 15 equals 0. All right, super important. What you gotta do, you gotta draw your Simpsons hand. So don't you dare draw 5 fingers. All right, draw your Simpsons hand. Color it in. Now, feel free to use your own hand since you'll be in real life. All right, so you get your Simpsons hand and you cover up this guy, and then you forget how to use Illustrator. You move it over there. All right, Simpsons hand has blocking this whole thing. It's been blocked, so you're going to solve this side. You know, if I could get a do-over on this, I'd make this bigger. Yet to scale. Hold on. Bear with me here. Yes. Not selected. Hold on. Now I'm messing up the scale. Well, there you go. Now my Simpsons claw is blocking that thing, which can't even see that. So I'm going to solve this part over here. So over here I have x minus 15 equals 0. Yes. Then, okay, I'll just work that. So then I get plus 15, plus 15. Then you get x equals 15. Nice. Wait, don't box it. Don't you box it yet. All right. Then you realize, I want to use the erase function, back out function. But now I did all this stuff. So let's remember x equals 15, okay? So back up, back up, back up. Back up, back up, back up, back up, back up, back up, back up. Now we get our Simpsons claw. Back up again. Man, forward again. Forward again. Not working. Okay, then we get our Simpsons claw over here. And we go, all right, make this bigger. Move. I hear you laughing right now. It's kind of rude. Oh my god. Okay, hold on. Go over here. Moving. Yes. Alright, so I'll go ahead. I'll edit that out before you see it. It looks seamless. So then what you do is Simpsons claw's blocking this side. So you're like, alright, so I'm going to write down 3x plus 4 equals 0. But because I learned from my mistakes, I'm not going to write that down. That's stupid. Okay, I'm going to go over here. Now I'm going to do that. I'm going to cover this part up and write this down. That's x minus 15 equals 0. Now I'm going to go ahead and write this part down. 3x plus 4 equals 0. Then I'm going to go plus 15. Wait. You can't plus 15 in black. I'm not communist here. Plus 15. Plus 15. So then we're going to go x equals 15. Go over here. Minus 4. Minus 4. And you're going to go 3x equals negative 4. Divide by 3. Divide by 3. X equals negative 4/3. Alright, so we have 2 answers. Super exciting. So we have, so you just write like on your answer thingy. Don't put commas and stuff. Just write them like this. Like x equals negative 4/3. And then write x equals 15. Don't even write the word and in there, because it could mean something different. Okay, so we got that. Next, 36. All right, 36 we have 5m squared equals 85m. That's right, I can read problems out loud. So we have 5m squared. And move the 85 over. Minus 85, minus 85. You end up with 80 minus 80. Wait, whoa, 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 whoa. We're not skippers in this household. We don't skip steps. We gotta go minus 85m, minus 85m. Now I'll tell you a real rook move. To be like 5m squared minus 85m and be on our merry way. Hello? You have an equal sign there. You gotta have an equal sign there. And 85m minus 85m is 0. But remember, I remember, I'll never forget. You need to have a 0 there. If you don't have a 0, if you end up with this situation, don't be in front of a group of 6th graders and try to think you can solve it like this. No, you gotta have a 0 right there. You gotta go over here, over here, over here, and you gotta move it over. You get your 0 right there. Then you're gonna go ahead and go 5, m, because we're distributors, minus, and then 85 divided by m. Quick mental math. You don't hear buttons being pressed in the background. Should edit that out. 85 m is 17. So I was like, in my head, like that. Alright, do some work in my head, because I totally know how to do this. 17, and then we go 17. Like that, and we go like that. Boom. Alright, by the way, seriously though, if you blank out on how to, what's it called? Divide, you can just do trial and error and just check your work. I think we talked about that. Okay. So, we have that, we have that. You're going to get 5m equals 0. And m, remember Simpson's hand? I don't really want to draw it. But if you had your Simpson's claw, first I claw this guy. What am I left with? 5m equals 0. Then, Simpson's broccoli this guy. Then I end up with m minus 17 equals 0. Boom. You get 5m equals 0. M minus 17 equals 0. Over here, divide. Now, you have a 0 on the top. It's 0. If you have a 0 on the bottom, it's undefined. Alright? Make sure that you don't think a 0 on the bottom means something, and make sure you don't want to you're like undefined trigger happy. And the way I kind of remember that is I think, alright, if you have like a slightly deflated soccer ball, there it is, and you have a 4x4, which is a piece of wood and kind of a truck, but it's a piece of wood that you could balance like this. Alright? So, can you balance a slightly deflated soccer ball on that piece of wood? You sure can. So a 0 on the top, a 0 on the top, yeah, that's 0. 0. But can you balance a 4x4 on Wilson? That's a reference to Castaway. That was a volleyball, I think. So you cannot. You cannot. There's no way you're going to be able to do that. So if you have a 0 on the bottom, if you end up with like a 3 over 0, that answer is undefined. But I can pretty much guarantee that you won't get an undefined thing on this test. You'll more likely get 0. Undefined is more like we do graphing type problems because it's a slope. So here you have m equals 0. Here you have plus 17, m equals 17. All right, so you have two answers. Box them. Don't put ands, don't put commas, don't put ors. Write them like that. Next, 37. 37 is 9x squared equals 1. This one's kind of interesting. This one you can do two separate ways. So I'll show you both ways. 37. The way the book probably wants you to do it is the way I'm going to show you first. Oh, look, I didn't write the problem right. Equals 1 equals 1. Alright, so book way. Book says, alright, divide by 9, divide by 9. Then you will pow it. Then you're going to get x squared equals 1 over 9. This is not the same as like don't have a non-zero number here, because we're going to use a different technique. So we're going to go root, but when you root, you need to plus or minus this side, like that. Plus or minus root. All right? And then that square root kills that square. Dead. So it just undoes that right there. Then you're going to end up with plus or minus. And then whenever you have roots, like fractions and roots, you can fraction the top. And I'm going to show you can root the top and you can root the bottom. All right. Well, everybody knows. I don't want to do it like that. We're going to go x equals plus or minus the square root of 1, which is 1, the square root of 9, which is 3. So you have two answers. So you can totally write it like that. Or you can write it as x equals 1/3 and x equals negative 1/3. Okay, that's one way of doing it. The other way of doing it is to bring the 1 over here. Have it like the other way we did it. So you're going to end up with a 9x squared. Wait, other way deserves a different color. Pretty much sure that's what colors are for. So we go like this. Let me go. All right, bring the 1 over. Bring the 1 over. Then you go 9x squared minus 1 equals 0. All right. Then we say to ourselves, I'm going to do my little thingy here. I have a difference of squares. That's like x squared minus 3, or no, x squared minus 9, and x squared plus 9. So that's really like this. Okay? So that means that I can say, oh, that's the middle wipeout thing. I'll take the square root of that, the square root of that, the square root of that. So boom, 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 boom equals 0. That leaves me with the square root of 3 squared is 3, and that's square root of x squared is x. The square root of 1 is 1. And you go like that again. And then it's the difference of squares thing. So it's plus and minus. And then you get your Simpson's claw, put over that, solve that part. Then you go 3x minus 1 equals 0. And then you Simpson's claw that guy. And then you end up with 3x plus 1 equals 0. Then you solve each one independently. So minus 1, 3x equals negative 1 over 3 over 3. X equals negative 1/3. Yes. There it is. Then you go plus 1, 3x equals 1 over 3 over 3. X equals 1/3. Yes. So you're going to get x equals negative 1/3 and x equals 1/3. And then we're going to box it. Last and least, we have number 38. That's the word problem. 38, we have the length of a rectangle. Partial credit number 1 on word problem. Draw picture. I can draw rectangles. I'm a good rectangle drawer. Check. The length of a rectangle. Length is the long way. The length of a rectangle is 3 centimeters more than twice the width. Okay, so these problems are kind of confusing. So 3 centimeters more than twice the width. All right, well, I know the width is W. Okay, so, and then the length is 3 more than twice the width. So I know I got a 2W right here. Right, so you're not going to have L's and W's. It's all going to be in one letter. If you have L's and W's, you probably did it wrong. So, at least for this test. So, I got twice the width, but then it's 3 more than that. Okay? So, it's 3 more than twice the width. It's kind of backwards because then you're like, when you're reading like the length of the rectangle, you kind of want to like, I initially want to be like, ah ha ha ha, length. Ah, twice the width. That's not what it's saying. It's saying this thing, this length, is equal. Oh, you know what? I think I might have a better way to doing this, by the way. So if you look over here, and you're like, all right, if you want to be like on ah ha 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 mode, you go, all right, the length is equal to 3 more than twice the width. You see that? the length, so I still have an L, makes me feel good about myself. L is equal to 3 more than twice the width. Then the width is the width, right? So, because it's all about the width. Width is 3 more than twice the width, right? So, somebody told me the other day, yesterday actually, that this was like when Hillary was running for president. And Hillary was walking into the White House with Bill Clinton, and they said, "Here's Bill Clinton and here's Bill Clinton and his wife, Hillary. Here's Bill Clinton and his wife, Hillary," which is kind of funny because she's the one running for president. But they introduced Hillary with respect to Bill Clinton, right? It was like you have, I don't know, man equals Clinton, and then woman equals Clinton wife. So they both have the same like letter in them. She's in fact, you can call it like C box, right? So she's like still, or I think you might have said Bill's wife or Clinton's, whatever. Anyway, hope you understand what I'm saying. It's all done like a, so here you want to have everything in terms of W. W and W. W and W. Right? So that's how you do that. So then over here, you don't write your L. You could, but you're done with the problem. You got it wrong. If your L, instead you're going to write 3 plus 2W or 2W plus 3. Then you have your W. Now we have to answer the question. Remember, don't set it up like this. Give yourself a high five and give it to your teacher, because we didn't actually answer the question. The area of the rectangle is 90. I'm going to put 90 in here. I like putting it. Writing the areas inside the rectangles. Okay, so then we go find the dimensions. No problem, because I know that length times width is area. So 2W plus 3 times W equals 90. I hate distributing like that, don't like that, not a fan of that. I'm going to go 2W plus 3 equals 90. Then you got distribute. 2W squared plus 3W equals, then just write down your 90. 2W squared, 3W, right. Bring the 90 over. Please learn from me. 2W squared plus 3W minus 90. Oh, and show your work too. Don't like jump the minus 90. Show the minus 90. Because you might actually mistake it and put plus 90. But then if you show the minus 90, A, you won't make the mistake, and B, you'll show work and get credit for showing your work. Alright, we got that. First rule. Whoa. Careless error, Steve. Doesn't go there. I might edit that out. Alright, so we have that. Now we're going to do the next thing, which is see if you can factor anything out. Does 2 and 3 and 90 have anything in common? No. Alright, so then you do the, oh crap, that's a 2 right there, type of factoring method. So you're going to go 2W, W. Then we're just going to guess, like 90. God, 10 and 9? 10 and 9. Then we got 20 and 9. Can 20 and 9 give me 3? No. Well, let's swap these guys. Let's put a 9 here and 10 here. That still gives me my 90 in the last. Alright, we got an 18 and a 10. Right? 18 and 10. No. And that's when things are about to suck. So then what you do over here is you put your factor tree, and you bust up 90 like nobody's business. So you go, alright, I know that 90 is 2 and 45. And I know that that's going to be 3 and 15. And that's, really, that's it? That's going to be 3 and 5. Alright, so this is so any combination of these numbers is 90, right? So I can go 6 times 15 is 90. That's 90. See, 6 times 15, that's going to be 90. I have any combination, so I could do 15 and 6, just kidding. I could do 9 and 10. See that? Yeah. That one's not going to be very helpful. And then I could do, running out of options. 2 and 2 and 3 times 3 is 9 times 5 is 45 is 90. Huh. And then I can do, what am I forgetting? Well, I don't have a 5 here. I bet you that's the one. So a 5, see 5, and the other one. So 6 times 3 is 18. So 5 and 18 is 90. Somebody didn't write a 90 here. Okay, so then we go here, and we say, all right, 5 and 18. Well, I gotta get a really tiny number 3. So, I could put an 18 here and a 5 here. Monster 36, baby 5, not giving me a 3. Or I can write my 18 and my 5 over here. This is getting awkward. Then we have 10 and 18. Still not giving me a 3. Because 10 and 18 is 8. Right? 10 and 18. So, did I overlook something? Let me see here. First of all, did I do this right? The length of the rectangle is 3 more than twice the width. So 2w plus 3. Yeah, everything looks good. Everything looking good. Wait. W times 3 more, yeah. And then I have w times 2w plus 3. 2w squared plus 3w. 2w, okay, cool. Yep. Yep. All right. So let's think here. That's why, by the way, this is the cry method. It sucks. All right, so we have, did I not do 6 and 15? Did I not even try that one? Hold on. 6 and 15. Ahaha! Just to let the record show. This lesson was to show you how to bust them up, and in real life, I would have attempted the first one. Why would I even continue to go on? First one didn't work out. Okay, so we have 12. We have 15. And 12 and 15 can give me 3. Which one's more powerful? Positive has to be more powerful. The 15 has to be more powerful. The 12 is the weak link because we have negative 12, right? That gives us a negative 12, and that gives us a positive 15, which gives us a 3. Nice. So then, I'll leave that there. So we copy our problem down. We got 2w plus 15, w minus 6. 2w plus 15, w minus 6. All right, so then we go ahead and, what's it called? Solve each one. It's equal to 0. Simpson's hand. W minus 6 equals 0. Then you do other Simpson's hand. 2w plus 15 equals 0. All right, so the first one is 2w plus 15 equals 0. The other one is w minus 6 equals 0. Minus 15. Minus 15. 2w equals negative 15. 2w. 2w. W equals negative 15 over 2. This one is plus 6, plus 6. W equals 6. Now you have a choice. You have a choice. You can make, this is approximately equal to, leave it as a fraction, but that's approximately equal to negative 7.5. All right? You have a choice. You can make your width on this real life application problem negative 7.5 or a positive number. That's length, right? That's like saying I'm going to travel negative 7 miles. So you can have negative length. Sometimes you'll actually get 2 answers, but in this case you just get 1. So you can disregard this one. Put a little slash like that, like boom, can't have negative. You can even write to your teacher like, can't have negative. Since he wants all the little, can't have negative. Yeah. And you have w is equal to 6. So then, first of all, you make your 6's look like 6's. Draw your rectangle. Width is 6. I think this one was 2w plus 3, right? Which is really just 2 times 6 plus 3, right? We'll just kind of get rid of that. That. Yes, move that there. All right, so that's that. Then, which is really the same thing as 12 plus 3, which is 15. So we got 15, and we got 6. And they want to know the length. Don't forget your units. This is in centimeter land. So you're going to say it's 6. Well, it doesn't really matter how you do it, but they always say length. by width, or I don't really know. So just go 6 centimeters. And you can write by if you want. By, you could do an X, but by might be cooler. By 6 centimeters. And you can check this answer, by the way, because 15 times 6 is 90. And is this, however they put it, the length is 3 more than twice the width. So I'm going to double my width, which is now 12, and add 3 more to it, which is 15. So it's done. Done. Yep. All done. Bye for now.